Let's go back up to the top for a sec. Hello, video people joining late. I'm just gonna, you pause the video when you need to see the answers. Here we are at the bottom. Okay, anybody else? Going once, twice, thrice, sold. You get to the end and then you say sold. Hey Alex, what's going on? Good. Love it. It's true. Okay, here we go. So this is BEDMAS yet again. First we did it with integers, then we did it with fractions. Now we're going to do it again with decimals. So I'm going to review some of your decimal math skills. We're going to look at how you add decimals, how you multiply decimals, how you divide decimals, which is stuff that you should technically have seen before. And so we are going to review. Here we go. So sign rules are important. It never hurts to review sign rules. They're the same with all numbers, whether they're real, rational, imaginary, it doesn't matter what that. All sign rules hold. So the sign rules are when you're adding or subtracting, when you subtract two negatives, does that automatically make something positive? Really quiet. I really appreciate you answering, but are you right? Let's see if I had -5. If I'm adding two negatives, what's -5 plus -3? I have two negatives and I'm adding them together. I'm two negatives, I'm adding them. If I'm at -5 and I'm bringing -3 and I'm adding it to the -5, is that going to make me positive or is it going to make me more negative? If I'm filling your boat with negative things by adding them to you one at a time, are you going to start sinking or is your boat going to be getting lighter?
Lighter.
No, don't do that. It's going to drag you down the number line. You're going to get more negative. Okay? When you subtract things, it doesn't also guarantee anything. If I have -5 and I'm subtracting -3, is that answer going to be positive or negative? There is something that happens with the negatives. I'm going to go over here. If I have I'll try here. -5 plus -3 is -8. -5 minus -3. There is something in here, though, that happens now. What happens with this? There's a very specific kind of double negative. Yes, Gershon. When you are subtracting a negative, these two negatives, because they are right beside each other when you're subtracting a negative, taking away something bad is the same thing as adding something good. Emma. Right? So this is, you can think about it like that. When you've got this kind of double negative, it's going to turn into addition. The final answer is still going to be negative, though, if it's keep your hands and writing utensils to yourself, or so help me. I will take them away. Your hands and your writing utensils. -5 plus 3 now. Is this thing going to be positive or negative? Not anymore. We're getting real in math class. Taking hands. -5 plus 3. What's happening there? What's that value going to be? -2. It's still going to be negative. Thank you, Charlie. So some of you guys are too quick with your negatives when you're adding and subtracting. You just take the one rule we have for negatives and multiplication and division, you're like, it applies everywhere. It does not apply everywhere. The rule for adding and subtracting, you actually have to stop and think. If I'm adding something negative to something negative, it's going to get more negative. If I'm taking away something negative, that means it's getting more positive. It might not be positive, but there is a difference between, guys, stop talking. There is a difference between becoming more positive and being positive. There shouldn't be a class going on out there. Anyway, whatever. So, there's a difference between becoming more positive and being positive. Becoming more positive means if you're negative, you're approaching 0. If you are above 0, you are growing. There's a difference. But the rules that you expect to hold Hold. For multiplication and division only. When I multiply two negatives, that's the same thing as, well, what is my result going to be then? Positive. I used Pac-Man to demonstrate this. It only works for multiplication and division. It also works for division because division is just a special kind of multiplication. Dividing by something is just the same thing as multiplying by a fraction. Let that rattle around in your brain for a while. So a negative times a positive is going to be negative. A positive times a negative is going to be a negative, and a positive times a positive is going to be a positive. It's nice and easy. It's clear cut for division and multiplication. You have to stop and think about it when you're adding and subtracting. I'm not even going to write the rest of this stuff up here. We're just going to scribble this part out. This is what I want you guys to roll around your heads. So, we're going to be looking at decimals and non-calculator stuff today. It's not as bad as perhaps you might think. Does anyone remember working with decimals and the basic operations earlier in your educational career? Does anyone recall this? Gershon does. Okay, Gershon, for addition and subtraction, what is the rule when dealing with decimals? You put what to the side? Ooh, that is bold. I am not familiar with this rule. I am thinking about a different rule. Perhaps this might work for you, but hold that, and I want to show you how I would approach it. Evney? Yes, this is what I am familiar with. When you are adding and subtracting decimals, you need to line up the decimals. So, if I have 5.97 and I'm going to add to it 2.701, my decimals in the two numbers need to stack. 2701. And then I add zeros to equal out the place values. This one only has 2 after the decimal. This one has 3. So I'm going to add a 0 to the top one to line up my place values. And then a longhand addition, just like longhand addition should be. You add down the stack, starting at the right, moving to the left. Well, increasing in place value, I'll say it that way. So 0 plus 1 is 1. 7 plus 0 is 7. 9 plus 7 is 16. So we put the 6, carry the 1 into the next place. And then 5 and 2 is 7, plus this extra 1 placeholder is 8. And when you're adding and subtracting, the decimals just stack all the way down. The same thing with subtraction. I'll do number 2. So 3.45 minus 1.45. You know what? That's a boring question. Let's change it. Let's change the second 5 into an 8. And let's not make it 1.48. Let's make it 1.482. Let's make it more interesting. So this needs to be an 8. And we're going to add a 2 to this. 3.4 minus 1.482. So just like the previous one, we stack the decimals. The top one doesn't no longer has the same number of places, so we're going to add a 0 there to line up the places. And then longhand subtraction had a particular technique to it. Top minus bottom, 0 minus 2. We can't do it, so what do I have to do to get subtract 2 from 0? Charlie, you were going to say something? No. Borrow. Ruben, was that you? Okay. It was Hayden? Hayden, I'm borrowing. You're right. So I'm going to take from the 5. The 5 becomes a 4, and I'm going to add whatever that place value is, to the lower place value. The 100th, I'm going to add it to the 1,000th, giving me 10. 10 minus 2 is 8. And now I move to the next chunk. 4 minus 8 doesn't going to work, so I'm going to borrow again. That 4 becomes a 3. That 4 becomes a 14. 14 minus 8 is 6. Now I'm going to go 3 minus 4. It doesn't work, so I want to make the 3 a 2, and I'm going to borrow again. 13 minus 4 is 9. and then 2 minus 1 does work, and then, which is good because there's nothing to borrow from. 2 minus 1 is 1, and we stack the decimals. So 3.45 minus our new question, 1.482, is 1.968. This is something you should have seen before. Things get a little weird when we do this with, yes, Jackson? Where's your booklet? Well, at least you were doing corrections. Yes, you may go to the bathroom because you're not even writing things on blank paper. Go to the bathroom. Watch the video later. I'm recording. Yes, I'm recording. Okay, so things get a little weird when you're dealing with negatives. Because this answer is going to be negative because I'm subtracting something larger from something smaller. So when you see a subtraction question like this, there's an extra step when you're doing it longhand without a calculator. What you need to recognize is that whatever happens, this final answer is going to be, I heard someone whisper it. Was that you, Andrew? It's going to be negative because I'm taking away something bigger from something smaller. So here, our final answer is going to be negative. And then the technique that I've seen for this, to do the subtraction, is as long as we remember the thing is negative, we're just going to go, now we're going to go bigger minus smaller. And keeping that final result being negative. So I'm going to take my bigger value, 12.41, I'm going to subtract it from 8.23. And because this was actually the original question, our final result's going to have to be negative here. But everything else stays the same. I need to borrow from the 4 because I can't take 3 away from 1. But I can take 3 from 11. That's going to be 9. Nope, it's going to be 8. 3 minus 2 is 1. The decimals line up. I can't take 8 from 2. But I can take 8 from 12. That's going to be 4. So then 8.23 minus 12.41 is going to be negative 4.18. I recognize it's going to be negative, and then I do bigger minus smaller, making sure I leave my final answer as being negative. That's the only other extra step here. Okay, do I need to do more than that, or can I move on? That's addition, subtraction. Okay, cool. There was a look of panic in your eyes for a second. Are we good? We're good? Okay. Dill Cronin, what we got? You have a 4-day weekend coming? You can stay awake now. Okay, here we go. Let's look at multiplication and division. Multiplication is nice. Division's going to be a little bit snarly, but that's okay. We can deal. Multiplying and dividing. Multiplying is straightforward. Let's do it. If I look at this question, I have two values. I can see that they're both negative. And because they're both negative, I need to recognize that my final result is going to be positive. Am I getting recorded? I'm getting recorded. Cool. It's going to be positive. So because I recognize that, instead of doing negative 2.3 times negative 0.81, I can recognize that because I've got two negatives here, it's the same thing as multiplying these two positive numbers together. It's the same. You need to take that extra step and be like, yes, positive. And so that's going to shortchange what we can do. I'm going to go 2.3, 8.1. I'm going to stack them again, except this time when multiplying, things behave a little bit different. When you multiply multiple digit numbers by each other, there is a pattern that happens here. We've looked at it before. We'll look at it again. I multiply the first digit by both of them in the numerator. So 1 times 3 is 3. 1 times 2 is 2. And then when I move to the next digit, I put a 0 down. And I multiply my next place by everything in the numerator, everything up top. 8 times 3 is 24, so the 4 goes down, the 2 stacks, and I'm going to add it. 8 times 2 is 16, plus 2 is 18. And now I add these two results together. 3 and 0 is 3, 2 and 4 is 6, 8 and nothing is 8, 1 and nothing is nothing. And now I've got 1,863, which if you think about it doesn't make any sense, because how could I multiply 2.3 and 8.1 and get 1,863? So what we need to do is we need to put the decimals in the right spot. Because what we do is we count up the number of decimal places. I have 2 decimal places here. And I put that many decimal places in my final answer. There were 2. I need 2. There it is. Questions about what I've just done? That is multiplication with decimals. It's fairly straightforward, I think. Yes, Rabin, is that a stretch? Cats, no, I still got to ask. Again, this is something you've seen before, bless you, Marcus, but maybe we need to review it. There it is. Does anyone have questions about what I've just done? Going once, twice, thrice, sold. Okay, so here is where things get more interesting. We are going to be doing some long division with the division, but we do something with it first, because dividing by decimals is weird. What does it mean? Some of these are going to be straightforward, like 3.2 divided by 1.6. It is entirely reasonable that some of you could crank that out in your head. The answer should be, can anyone crank that out in your head? At least some of you should be able to. Avneet? -2. You betcha. How'd you do it? It's just like 32 divided by 16. And 32 divided by 16 we should be able to do. 32 divided by 16 is also 2. So here's the technique for dividing by decimals. What you want to do, because division is just a fraction, one of the things that we can do with fractions is write down an equivalent fraction to make our life easier. This is the same thing as 3.2, actually, well, I'll make it negative, -3.2 over 1.6. This is the same. And one of the things that we're allowed to do with fractions is write an equivalent fraction to make our life better for whatever reason. So to do that, we're going to multiply the top and the bottom by the same value. In this case, to make it 32 over 16, we have to multiply both of them by 10. When I do that, I'm going to get -32 over 16. And then if required, we long divide, or if you see something nice that you recognize, long division is not required. We can be like, oh yeah, this is just going to be -2 because 16 goes into 32 twice, and a negative divided by a positive is negative. So the technique with this, and I'm not going to write it out this way every time, the technique for this is to multiply both of these values by a power of 10. The only other piece here to decide now is which power of 10. Here's how we do it. Let's look at number 4 to determine which power of 10. Only one of those 2 decimals matters. There's one that will make our life easier to deal with. And that one is, which one? Does anyone know? Rabin, do you have a thought related to what we're talking about? Because you have lots of thoughts. They're just not all related. Okay, the only fraction, the only decimal that really matters, that we have to turn into a whole number like we did down here, because that was the whole point, is to turn these 2 into a whole number. The only one that matters here is the thing that you're dividing by. If that one is a whole number, everything else gets easy, because if you remember how we did long division, we regularly added decimals and zeros to what was going on inside here. But we never want to have a decimal out here on the outside. No decimals outside. And the thing that's on the outside is the thing that we're dividing by. So to get rid of those things, I have to multiply both of these by the same power of 10, and only the power of 10 that'll actually move my decimal away. So what do I have to multiply this? How many times do I have to move the decimal here to get rid of it? I have to multiply it once, so I multiply it by 10. To get rid of it this way, we multiply this by 10, and whatever we do to one, we have to do to the other. So this is going to multiply this by 10, moving the decimal once. So this new question is going to become, it's actually not new, it's an equivalent question, 0.5 divided by 1. Oh, look, does dividing by 1 change anything? No, it doesn't. Dividing by 1 is just itself. So 0.5 divided by 1 is 0.5, and we're done. Shall I do another one, Raven? I was going to do 5, but we can do 6. I was going to do 5 and 6, but, you know. Both of them? Let's do both of them. I have the time. Because it's useful for you to see me do them so that when you do them on your own, you're not totally lost. 100%. Because I'm going to assess whether you can do it, so Raven's got the right idea. Let's have Dweedoff show us as many as he can so that when we go do it ourselves, we're not totally lost. Is it? Well, that's not as ideal. Here we go, number 5. BEDMAS says what happens first in 5? Okay, B stands for brackets. Is there math inside those brackets? Nope. So B is done. Are there any exponents? No, because I've purposely not included them till next chapter. Is there division? Yes. Is there multiplication? Yes. So when you have division and multiplication together, thank you, Emma. Yes, that. We go in here. I'm going to write it out again. We have BEDMAS. There's no brackets, exponents, but there is both of these. When both are present, it doesn't matter if it's multiplication first or division first, whatever it is, we're going to go left to right with division and multiplication. So the first thing we're going to do is we're going to multiply the negative 0.2 by 31. So, negative 0.2, actually I'm going to write it this way. I'm going to go 31 times negative 0.2. So my final answer is going to be negative, because one of them is negative. And so it's going to be 2 times 1 is 2. 2 times 3, 6. Not 3. Okay, Dweedoff, figure it out. Negative, that's a 2, that's a 6. And I'm done because there's nothing, that's a 0, right? So I'm not going to multiply everything by 0. It's just 2 times those things. How many places of how many decimal places do I have in my question? Sorry? How many decimal places are in the things I'm multiplying together? 1. Only this one has a decimal place. And so I need to put a decimal in my answer down here to reflect that. So this is going to be negative 6.2. And now we need to divide. I'm taking negative 6.2, and I'm going to divide it by negative 0.31. Oh, look, this double negative here. I can take, because I'm dividing two negatives, this is going to be the same thing as 6.2 divided by 0.31. I can make them positive because there's two negatives being divided. And now I'm going to multiply by a power of 10 to move the decimal in the thing I'm dividing by. So I'm dividing by 0.31. So what power of 10 do I need to multiply both of these by to get rid of this decimal place? I need to move it twice. So I have to multiply by 100. And whatever I do to one, I have to do to the other. So this one's also going to move twice. But oh look, I created a gap. So the question now is going to become 620 divided by 31, which if we needed to do longhand, we can. The 31 goes on the outside, the 62 and the 0 go on the inside. It's still kind of grossish because it's 31, but it's a nice question because 31 looks an awful lot like what? Oh, it kind of looks like 30. So if I just ignore the 1 and the 2 for a second, 30 times 2 would be 60. But it's not 30, it's 31. But what's 1 times 2? It's 2. So 31 times 2 is going to be 62. Bring down the 0, bring down the 0. How many times does 31 go into 0? 0 times. 0 times 31 is 0, and we're done. So this then is our final answer after all that work. Actually, not that much work. You might look at that and say, oh, that's so much work, but then again, you have no idea what awaits you in the future. Well, I've alluded to things like the questions just get bigger. What do I mean by that? Okay, real quick. When I was in I'll just use this to demonstrate. You guys, that's one little line we chunked up top there. You'll hit grade 12 or grade 11, depending on what math class you take. Sometimes one question, whole page. When I was doing my undergraduate degree, what we would do, I'll show you over here in more space. What we would do in some of my physics classes, single question. You'd be like, okay, question 4. We put the paper down, and we only used one side of it for a reason I'll demonstrate, and we just started going. And we moved to the next page, and we moved to the next page. If we found a mistake, we didn't erase anything, we just threw away all of the pages at the mistake and passed. Put down new paper, and kept going. What about the trees? Yeah, what about the trees? We are putting their corpses to work. The paper already exists. At this stage, I'm more concerned about recycling than I am about recycling. But that's how we had to do it. The other alternative is what we started doing later, is we would actually move to the whiteboard and just go. We had whiteboards, we had 4 whiteboards at UFV, and the way they worked is it was 2 side by side, like the ones that Alex is in front of, and then there were 2 more that would slide down over top of them. So it's 4, 1, 2, 3, 4. So we'd slide down these 2 and we'd go. And then we slide them up and we keep going. And when we're done, we stand back, we take a picture, save it as a PDF. Pull them all down, erase everything. Question 2. Start again. Or some of our assignments, there might have only been, like one of my final exams only had 3 questions on it. One of the questions had, I kid you not, A through M lettered questions, single question, and every letter built on the previous letter. It wasn't like some of the questions I gave you where A, B, and C aren't related to each other at all. You're going to get problems where here's this piece, and this piece, and this piece, and you have to do that piece, and that piece, and they're going to stack. Like, we have no concept at this stage. You guys don't have a huge concept of where some of this stuff can go, but it's really cool where some of this stuff is going to go in the future for you guys. So here we go. Let me keep going. Rabin, yes, I'll take your. When did I go to university? Many years ago. Fewer years ago, but still many. Like when I graduated high school or university? 2006 is when I graduated high school in 2005. University was fall of 06 to spring of 2010. And then I did my teaching degree the year of fall of 2010 to spring of 2011. And then my master's was later. A while ago. When were you guys born? 2010. Okay, cool. So I was graduating from university the year you guys were born. Yeah. Okay, last question. Here we go. Bed mass. What am I doing first? Is there math in brackets, Colt? No. Okay, so bed mass, let's write it out. B-E-D-M-A-S. Brackets, no. Exponents, there are none. Is there division and multiplication? You bet there are. Are they connected to each other? No. They are separated by addition. So I can do them separately and together. See what I mean by this? I'm going to take my negative 2.1, I'm going to multiply it by 3. So 2.1 times 3, because it's negative, my final answer is going to be negative. Toss it in there. 3 times 1 is 3. 3 times 2 is 6. That's a 3. How many decimal places are in the things I'm multiplying? 1. So there's my decimal place. I'm going to jump over here. So I'm going to get, well, let's go here, negative 6.3 plus, okay? Now I need to do this piece. What's 4.2 divided by negative 0.6? Well, that answer, whatever it is going to be negative. And now I'm going to change this question. It's not 4.2 divided by negative 0.6. I'm going to do what to these two numbers? I have to multiply them both by something. I'm going to multiply them both by 10 because I only need to move the decimal place once in the second value. So this thing's going to become 42 divided by 6. I'm going to do it longhand. Well, we don't really need to do it longhand. Longhand isn't going to work here because 6 doesn't go into 4, so does 6 go into 42. You just need to know your times tables or use the chart I gave you. 6 goes into 42. I heard it 7 times. So because these are equivalent fractions, it's not like I need to move the decimal place around anymore. This is it. It's just 7. So my question then is going to become negative 6.3 plus negative 7. And this you should be able to do without doing any stacking. Negative 6.3 plus negative 7. If I'm adding two negatives, this thing is going to become more negative. And 6.3 plus 7, well, what's 6 plus 7? 6 plus 7? 13. So 6.3 plus 7 is 13.3. There's my final answer. That's how I would do this. And again, technically speaking, most of this is review of what you've done before. It just might have been a little while, which is why we practice. But if you're sitting there being like, this is entirely brand new, then let me know and I will work with you. Here's what I'm going to release you guys to do. Flip the pages here. Take a look at what I've got. Okay? This page, grade 9s, hang with me here. This page here is, guys, Raven, stop talking. Hayden, shush. Don't, Raven. Do not police Hayden for me. I will do it. He was saying something to you. I told him not to. I don't know why he read. Just don't worry about it. I'm not mad at you. I'm mad at Raven. He was policing people he didn't need to police. This page is more fraction stuff. We've done it already. This is optional extra practice. You do not have to do it unless you're struggling with these things, in which case you've got more questions. Flip the page again. Oh, look, more fractions. This is also optional. Some of you might benefit from doing the practice, but I will not require it of you. Flip the page one more time. We've got some awesome BEDMAS with fraction questions. And if you look down here at the bottom, we finally have some decimal questions. This chunk right here is not optional. This is what I want you to do. And actually, I want you to do this guy down here too. We're going to look at these are very simple word problems. We're not going to be doing a lot of really gross ones, but you still need to be comfortable reading a sentence in English, or I mean, if you want to pull out a translator, I suppose you can pull out a translator, and turning what's here into, I'm not being racist, stop talking. Just, shh, Raven. This is homework. This is homework. I'm going to do one of these questions to demonstrate what I will flip the page again. This is also homework. And there are many of them. Many, many, many. So many manys. There is 44 of them.
44 word problems?
Yes.
Yeah.
Okay. I think there's 44. Or did I cut off some of them? Nope, I left them all. Okay, so what I want you to take a look at here, I'm not answering your question right now, I will in a second. I want you to take a look at questions 1 to 24, and I want you to do multiples of 3. So I want you to do question 3, 6, 9, 12, 15, 18, and 24. 21 and 24. So 1/3 of the questions. I will do one of them for you here. I will do question number 1. So if you think about, I'm going to read it to you. Callie will be 43 years old in 13 years. How old is she right now? Okay, so y'all, a bunch of you, I heard 2 people's voices already. She is 30 years old. That is correct. What did you do? What I want you to show me is that you can demonstrate the mathematical thinking on the paper that you did in your head. What did you do to determine how old she is now? I think, Charlie, was it your voice I heard with Raven's voice? Was it Andrew? I heard someone over there say, Andrew, was it you? You said 30? How did you do it? What did you do? Yeah, you took the age in the future and you subtracted how many years had passed. 30. These aren't super difficult, but you need to demonstrate the thinking. Like, let's do another one. Let's do number 3. For her birthday, Beth was given $17.90. Now she has $53.30. How much money did she have before? Raven. Oh, you didn't finish your question, the top one? I mean, there's not a lot to finish there, but finish. No, I don't want to do number 3. Number 3 I assigned. Let's do number 4. Deshaun spent $33.60 on batteries. If they cost $4.20 per pack, how many packs did he buy? Okay, how do you determine the cost of a single pack if I give you, how do you determine the number of packs if I gave you the cost of 1 pack and the total amount of money spent? The total cost divided by the price for 1. Very good. So the total cost is $33. Come on, to weed off. $33.60 divided by the cost for 1. This is still going to suck here a little bit. We are going to do this longhand, we're going to multiply both of these by, who said 100? I could, if you followed exactly what I said before, you'd multiply by 100 to move the decimal place twice. But do you need to multiply by 100? Why not, Marcus? Because there's a 0 there, and there's nothing after the 0. So we can multiply by 10 or we can multiply by 100. In this case, multiplying by 10 is easier because that 0 alone after the decimal place doesn't change the question. This thing's, and whatever we do to one, we have to do to the other. So this is going to still be 336 divided by 42. This is still pretty terrible. We're going to have to do some guessing here, certainly. Let's try it. Long division. 336, 42. Here's how I would try and do some guesstimating in my head. Actually, no, I'll put it to you guys. Does anyone have any thoughts about where we could start with this thing? 42 obviously doesn't go into 33, so we do have to go straight to 336. Let's make it, so what I'm, oh, yeah, Raven? So, that's his choice. Yes. No, you may not. I'm almost done the questions I'm demonstrating. So, what I've tried to demonstrate in the past are ways to make your life a little bit easier when picking some of these values. So what I've tried to demonstrate in the past is instead of going 42 into 336, what I would look at perhaps is 4 into 33. How many times does 4 go into 33? 8, because 8 times 4 is 32. So let's try 8 and see what that gives us. 8 times 42. Let's do it longhand. 8 times 2 is a 6, carry the 1. 8 times 4 is 32, plus 1 is 33. Oh, look! Way to go, Emma. You found it. I didn't say anything.
I did.
We'll talk. Okay, so there's your answer. it goes in cleanly, your answer is a no calculator required. Certainly would make your life easier, but it's not a necessary tool for you to do these problems. Okay, so you've got 20-ish minutes. This is what I want you to do. This guy, and 1 to 24 multiples of 3. Raven, question. Question J.
Yeah, what's that symbol type 2?
Okay, this is a fantastic question. Glad you asked it. This is cut off by the photocopier. These are square brackets that match up surrounding what this is. It's just another way to write brackets. What? They're not exponents. There's another set of brackets. Sometimes we use two different symbols for brackets to help you see which ones are paired with each other. So these two square ones are on the outside of the 2.8 plus the negative 3.5 in brackets. They're different kind of brackets, but they're just another brackets. It's like how Amazon ships things in different size boxes. A box is still a box, even though it looks a little different. Okay, there you go. Just a different kind of package. Okay, I will walk around and help where needed. If you need blank paper, on the desk next to Andrew, there's a stack of it. Use with right next to the hole punch. Feel free to take what you need. Shobit's available for helping you. I'm available for helping you. If you want to move to the boards, I would encourage you to use some of that space. I am going to run down to the photocopier and see if I can get your reviews copied before you guys are gone. On your markets at go.